In today's video, I'm going to teach you how to perform t-tests in Microsoft Excel. Start by opening Microsoft Excel and creating a new blank workbook. We'll use a simple example to keep things clear, but the same process works for larger datasets. Before we begin, a quick refresher. A t-test is a statistical test that compares the means of two groups to determine whether the difference between them is likely due to chance. The key output is a p-value. Smaller p-values suggest stronger evidence that the groups are truly different. A common threshold is 0.205. Now prepare your data. Put your two groups in two separate columns with no blank cells, no text, and the same number of rows. For example, in column A, enter group 1 values like 10, 20, and 30. In column B, enter group 2 values like 12, 18, and 25. Keep each observation on its own row, so the entries line up across columns. This structure helps Excel correctly compare the groups. Next, choose a blank cell where you want the test result to appear. Type the t-test formula, which looks like this. Is t-test, array 2, tails, type. Using our example ranges, you would enter t-test, A2, A4, B2, B4, 2, 2, and press enter. Here's what each part means. The first range, A2, A4, is your first group. The second range, B2, B4, is your second group. The third argument, 2, specifies a two-tailed test, which checks for any difference in either direction. Use two-tailed when you don't have a specific expectation that one group should be larger than the other. The fourth argument, also 2 in this example, tells Excel to run a two-sample test assuming equal variances. For context, type 1 is a paired test for before and after measurements on the same subjects. Type 2 is for two independent groups with equal variances. And type 3 is for two independent groups where variances may differ. Excel will return a single number, the p-value. In our example, that value is 0.2. To interpret it, compare it to your chosen significance level, commonly 0.05. If the p-value is less than 0.05, you have evidence of a statistically significant difference between the two group means. If it's greater than 0.05, as 0.82 is here, you do not have enough evidence to conclude the means are different. In plain language, we fail to reject the idea that the groups come from the same underlying average. A few quick tips as you wrap up. Ensure your ranges contain only numbers, avoid blanks, and confirm the tails and type match your study design. Clear setup leads to clear results. If the video has been helpful and want more tips, please subscribe to the channel. It's free.